Hi there. In this video you see here two figures. In this figure the graph for each of sine and cosine. You see from the graph of sine in this green color, it's periodic, and so also for the cosine graph, it is periodic, and the length of each period is 2 pi. Here, see, if you consider this the origin point, so this distance is the length of the period. The period start from 0 here, go up till the max point, which is at pi over 2, sine getting 1, value 1, and going down again to 0 when the angle is pi, and it go down more to -1 at 3 pi over 2, and they start to go up again to get 0 at 2 pi, and repeat itself each 2 pi's. This can be explained here when we draw any angle in the standard position, where the vertex of the angle at the origin point here, you know the initial side will be at the x-axis positive side, and the terminal side of the angle decide what's the quadrant the angle lying in, like here. This the terminal side of the angle, as it is lying in the first quadrant, so the angle, we said all the angle lie in the first quadrant. Let me see, this is theta. If we consider here another angle started from 0, where the initial side at the x-axis positive side, and it's running where it is getting 2 pi plus theta, so it's retained back at the same position of the terminal side. So this angle here in the blue color, it's theta plus 2 pi. So the same terminal side of the angle theta coincide on the terminal side of the angle theta plus 2 pi. That means the difference between the angle theta and the other angle is just 2 pi here. And also, if another period we can do, if you continue by drawing another angle, see here in a green color, this angle here, when it is stopped at the same terminal side, so the third angle, which is in green color, it's theta plus 2 pi and another 2 pi, that's mean 4 pi. So each period will give me 2 pi added to the previous angle. So each angle repeated after adding 2 pi. And same thing if we draw in the negative side, in the negative direction I mean, it will be theta 2 pi minus theta 4 pi minus theta 6 pi minus theta, and so on. That's why the graph, when we draw it, we got it like this shape. It's repeating itself every 2 pi. Look for these values. Here I will write it about angle theta. Theta 0 radian, pi over 3, pi over 2, 3 pi or pi over 6, let me take pi over 6 here, pi over 6, here pi over 3, here pi over 2, and start to add this to this. It will be 2 pi over 3, 3 pi over 4, 5 pi over 6, and so on. Let me here get 1 pi. So the values, the ratios values for these angles for sine theta, it will be 0 here, be 1/2, here square root of 3 divided by 2, here is 1, and repeated again. Here negative, it will be negative. And the first pi still positive, because this is the first pi here from 0 to pi. But after the first pi, from pi to 2 pi, it changed into negative, because there is rule control the signs said here. 4 quadrant. In the first quadrant, all the functions are positive. All are positive. Let me say for all A. For the second quadrant here, only S is positive. That means sine only is positive. And the third quadrant here, only tan is positive. Tan is positive. And the last quadrant, the fourth one, cosine is positive. You see? This the rule control the signs. We can give it in one statement. Said all for the first equation, for the first quadrant, all S like the first letter of student, T, the first letter of take, C for, let me say, calculus. calculus. So all students take calculus. All for the first quadrant. Plus. That means sine plus, cosine plus, tan plus. That means the word all. For the second quadrant, we said student, the first letter S. That means only sign is the positive. The third quadrant here, T is the first letter of take. That means tan. The first letter for take is T, which is the same starting of tan. Tan is positive at the third. And calculus, the first letter is C, which is the first letter of cosine, is positive at the last quadrant. So this is the same meaning when we said all in the first quadrant, sine in the second quadrant, tan in the third quadrant, and cosine in the last quadrant, which is the fourth. Those are the positive. Others will be negative. Like here, none is negative, but here cosine negative and tan negative. Here we say the others are negative, which are sine and cosine. Here others are negative, which are sine and tan. So this is the way we decide the sign of in each quadrant. So here we still in the first quadrant is between 0 to pi over 2. From 0 here to pi over 2 here. So this is the first quadrant. From 0 to pi over 2. Here, this distance. Sine is positive, as we talking about sine now. From the starting of second quadrant, from pi over 2 till pi, here pi. So this is the second quadrant. From pi over 2 till pi. Pi over 2 to pi, here. Still sine is positive. So all the values here still positive. Third quadrant, which start after pi till here, from pi till here, which is 3 pi over 2. Here we say sine is negative. Here in the third quadrant, the only thing is positive is tan. So here, as we talking about sine, sine is negative. That's the third quadrant, and so on for others. Anyway, after doing all the values for this here, one half, here is 0, here is 0. So here is 0 and here is 0. And this, the maximum point at pi over 2. You see here the graph? At pi over 2 here, here's pi over 2. Here's 0. Here's pi over 2. Here's pi. 0 start with 0. Pi over 2 will give me the maximum point, which is 1. Here 1. Coincide with 1. So this point here is pi over 2 for x one for y. You see? At this point, pi for x and 0 for y. This point here, at the green curve, this point here is 3 pi over 2 here, 3 pi over 2 for x, 3 pi over 2, and negative 1 here, negative 1 for y. And so on. This is the graph for sine. And in red color, the graph for cosine. We can write the result for this graph we got is sine theta is the same as sine theta when we add 2 pi here, because the length of the period is 2 pi. Just the difference, the length of the period. The first period here from 0 to 0, this graph here from 0 to here, and the other period from here to here, and so on. And in negative also, this period here. You see the cycle, complete cycle. Here from negative 2 pi till 0. Here from 0 till 2 pi. Here 2 pi. From 0 till 2 pi here. The second from 2 pi till 4 pi, and so on. And we say the same thing for cosine. We can say for cosine theta is the same like cosine theta plus 2 pi. This result arises from considering the graph of these two functions as periodic. So the function themselves are periodic. When you look for this graph, for this figure 2, this gives me main result here. The main result we got them from this figure say that when we replace theta by minus theta or by negative theta, we got sine will be equal to negative sine minus theta, while cosine theta is the same like cosine negative theta. Because here, just for instance, for just an example, if we consider this point at the terminal side of the angle, sine theta is this over this. So 3 over this by hypotenuse by Pythagorean theorem, you can find it's like square of 4 plus square of 3, that's mean 16 plus 9, that's mean 25. The square root for 25, that's 5. So this is 5, the hypotenuse. So when you write sine for this angle, sine theta, see, You are right. Sine the angle here. Sine is opposite on hypotenuse. Opposite is 3. 3/5. While sine negative theta here, this is negative theta. Sine is opposite over hypotenuse. Opposite here is -3. The coordinate for this point is -3. So we said -3 over the hypotenuse, which is 5. So what's the difference between them? They are not equal. They are different in sign. So we say sine theta is not the same of sine negative theta, but it's different by just sign. What does it mean, this? This means when we change the angle into a negative angle, we did not get the same function. So this function is odd. This function is odd. It doesn't even. It will be even if we got the same value when we replace theta and negative theta. Like for cosine. Look what will we do for cosine. For cosine here we can say cosine theta in this figure. Cosine theta is the adjacent over the hypotenuse. Adjacent here is the first coordinate of the point, which is 4. 4 over the hypotenuse 5. Cosine negative theta also still the adjacent. Here's the adjacent over the hypotenuse. Adjacent here is the same coordinate here, which is 4 also over the hypotenuse 5. So it's the same value. When we replace theta and minus theta or negative theta, we found the same result. That means cosine theta or cosine negative theta are the same. This means this function is even. So we have two functions. One of them is even, the other is odd. Which one is the odd and which one is the even? Sine is odd and cosine is even. Okay? Let me solve an example for you about finding the ratios of angle when we know just one ratio of that angle. Here the question said, find the remaining ratios for theta or for any angle like phi as or where tan phi is equal to 3 and phi is between 0 and pi over 2. This equation here. How can we solve this equation? We know from the definition of tan for any angle, it is the opposite over adjacent. Here, if we said here is theta, and this opposite, and this adjacent, and this hypotenuse. Here, as they said, tan phi is equal to 3. We can consider here number 3 as ratio number. Ratio like a rational number. 3 over 1 to matching the number here with opposite and this number here with adjacent. So this one will be the opposite and this one will be the adjacent. And this will help me to find the hypotenuse. So we say hypotenuse square is equal opposite square plus adjacent square. This according to Pythagorean theorem. And as considered tan phi is equal 3, which is mean 3 over 1. So we consider opposite is 3 and adjacent is 1. So we can make substitution here. Hypotenuse is equal, hypotenuse square is equal opposite square, that means 3 square plus adjacent 1, so adjacent square is 1 square. That's mean 9 plus 1, which is mean 10. So the hypotenuse square is 10. Then we said hypotenuse is square root of 10. Okay, now we consider all the sides of the triangle are known. Here is 1, here is 3, here square root of 10. And this is the angle phi. So we can write all the remaining ratios, and don't forget to consider the condition here. The condition said the angle phi is between 0 and pi over 2. That means it is in the first quadrant. When it is in the first quadrant, that means it is positive. And all the other ratios are positive. So we can write here, because phi in first quadrant all ratios of angle phi are positive. Then we can write all as we found all those sides. So we'll write them here. Then we can write sine phi, cosine phi, tan phi, and their inverse also, their inverse, which are here cosec phi, here sec phi, and here cotan phi. So what are the values? From the definition of each of those, we can write them. Sine phi is opposite over hypotenuse. So 3 divided by square root of 10. Cosine is adjacent over hypotenuse. Adjacent over hypotenuse. Tan is opposite over adjacent. 3 over 1, that's mean 3, which is given from the beginning of the question. And the inverse of each of those will give me those. The inverse here, it is square root of 10 divided by 3. Here square root of 10 divided by 1, that means square root of 10. Here 3 over 1, that means 1 over 3 is the inverse. And this is the end of the question, the solution of this question. Okay, this is you. We will continue in part 4. Thank you for watching. See you again.